So today we will discuss about another tool of data structure, very important. That is, so we have to learn how the queue uh, works, functions like stack. Here also we will be implementing the different operations to manipulate a queue, right? So we'll first show the two operations mainly on queue, like stack. In case of stack, we discussed two operations, push and pop operations. Here, to insert an element to a queue, we will call insertion, okay, or addition. And to remove an element, we call remove, right, or deletion of element from queue. Like stack maintains a particular principle LIFO, last in first out. The element which gets inserted last will be removed first. Here in FIFO, Q maintains FIFO, first in first out. Right? The element which will be inserted first will be processed or will be removed or will be deleted from the queue first. Like say in your real life, if you stand in a queue to get any service processed or to get anything solved for you, the person who stands first will be processed, will be served first, like a first come first serve. This principle we maintain in queue in real life, so that we will try to discuss in an algorithmic pattern which will follow to write coding, write a program in C, right? Let us start with that simple example, a real life situation. Here, first in first out, so many cars are standing in a row, first in first out. Okay, its principle, it will be processed, it will leave the queue, right? So likewise the data, this is a symbolic presentation of your queue, and you can see that data will be processed one after another, and the data which inserted first will be processed first and will be put out of the queue first, right? So basic operations are to insert an element or to add an element in the queue. We will call it NQ operation, like push, right? If we want to add or put any element on the stack, we call it push, like that. Similarly, NQ operations and DQ operations, when we want to remove an element from the queue, it will be DQ operation, deletion from queue, right? Peak in stack, two parameters are very, very important. Two parameters. One is the knowledge about the top, its position, the position of the topmost element, right? That index by top, right? And second one, the number of elements, maximum number of elements we can put on a stack, right? Otherwise, if we still, after the stack is filled up, if we want to insert another element, stack overflow error will occur, right? That we discussed. And this constraint we need to put always. Here also, there is a limitation, because first we will discuss the implementation of the stack or queue using static memory allocation. You know, in static memory allocation, memory size is a constant. That how much memory we are taking to define a stack, or how much memory we are taking to define a queue. It's array. Example is the array. So static memory allocation. Constraints are not valid for the dynamic memory allocation. Why? In case of stack, why you always need to check the constraint whether the stack is full or stack is empty? Because we cannot modify the size of the memory, or we cannot redefine the size of the array at the time of execution or at runtime of the program, right? That will be fixed beforehand. But in case of dynamic memory allocation, there is scope for us, for the programmer, or for the program rather, to allocate the memory as and when required. So you can keep on allocating the memory whenever a new record or new element is needed to be added or to be pushed or to be to keep in the queue. So we can create. So generally that kind of occur, that kind of error, or that kind of constraint, we don't need to bother about. General sense, but don't consider anything absolute, right? There may be an error may encounter, but exceptional case. In case of exceptional case, when we will run out of memory, right? If the memory runs out, then how the system will allocate memory at runtime, right? But this kind of situation generally doesn't occur. It generally occurs for the programs which take huge data, right? That kind of a situation hardly occurs, right? So we will not consider that exceptional case. So here, these constraints are to to put these constraints in mind only needed when we will implement the stack or queue using static memory allocation, right? Using array as a feature of any language like C. Okay. So what you are discussing, you can see the enter screen. The enter screen is visible to you?
No, sir.
It's not. So to tell
No,
me.
sir.
No, sir.
Yeah. Oh, I didn't start presenting. Anyways, you enter screen. Someone is trying to join. Share. Yeah, presentation is starting. Now the enter screen is visible to you?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So just we already discussed this one. This is a real life scenario of Q, right here, and here is a technical uh, 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 diagram where each and every data will be uh, processed by the queue, and the data which will come first will be processed first and will be left out of the queue, right? So the basic operations are that enqueue and dequeue. To add or to store an element in a queue, we will call it enqueue operation, and to remove an element from the queue, we'll call it dequeue operation. Like, and peak, what peak does? Peak generally gets the element which is located in first. And what we are discussing, that in stack there was a very important parameter that is top here in the, like this. We will consider two parameters, front and rear, not one parameter. In stack, one parameter is sufficient, that is top, which gives us the knowledge about the position of the topmost element in stack. Here, we have to always keep track of the knowledge of two parameters like front and right. Sharikan, those who are joining later, please try to join in time. Otherwise, you will be missing the preliminary discussion, which will be difficult for you to understand the the lecture if you don't attend the lecture from beginning. Anyways, so like peak always gets the element of the front, the position, the element which is there in the front position. Like stack here also we will check whether the queue is full or not and is empty, whether queue is empty or not. That will check. The general algorithm peak. See here you can consider the name of the array is queue and by the index definitely the index where the front element is placed will be denoted by the front. So q front generally access the element which is there in the front position in the queue, right? So is full means if say let's say there are 5 elements, if there are 5 elements, right, then see here we talked about front and definitely I told you that there is another important parameter rear. Rear points to the element which is the last element in the queue. Now may I ask you a question that if there is no data, if there is no data in the queue, what will be the value of front and rear? Answer me. If there is in the queue, what will be the value of front and rear? I told you that front points to the first element in the queue and rear points to the last element to the queue, right? So when there is no data in the queue, what will be the value of front and rear? Answer me.
The
Good answer.
garbage well.
Hmm?
The garbage well.
I didn't listen to you. What? Garbage value? You can. The answer is accepted. Garbage value. But generally, we don't. Explicitly, we remove the garbage value at the beginning of the right. We initialize it by what? By what? Generally, if we utilize the variable in a program, the general convention is if we don't uh, define variable with any value, by default it holds the garbage value, right? We discussed it in your second sem. So general convention is to initialize the variable with 0, na? Right?
Yes, sir. Right.
Yes or no?
Yes, sir.
Yes,
So
sir. Yes, sir.
in this case, with which value we will initialize for the front and rear? Which value we should initialize with? Hmm? What about the girls? Sneha, Sneha, there present in the meeting?
Yes, sir.
Uh, answer. If there is no element, then initially with the which value we should initialize the front and rear?
Sir, can
Hmm?
you repeat once more?
I told you, you are there in the class, no? Right from the beginning, you are listening.
Yes, sir.
I told you there are two parameters, important parameters are there, front and rear, to manipulate or to handle the queue, right? The element which will hold the first element, the position is called the front, right? Front will point to the first element in the queue and rear will point always the last element in the queue, right? The current position. So when there are no elements in the queue, we didn't start adding the elements in the queue. So with which value we should initialize the front and rear with? Hmm?
Sir, -1 for empty queue.
Hmm? Shantan,
Sir,
carry
means
on.
-1. Sir,
Exactly,
-1 for
exactly, absolutely right. And people couldn't answer this one. It took time. Why? Instantly you should answer, na? If you concentrate on the, I always told you that always try to uh, keep the concept pictorially. Always pictorial representation becomes easier for us to remind or for us to uh, think about the topic. Okay, pictorial representation is always best for this. So if you see it here, if there are no element, there's no element, then front and rear definitely will point here. First position, if there is only one element, now answer me. If there is only one element in the queue, then front will have what? Which value? According to the concept of array, front will have 0 because the array index starts from 0. Right? So the front will always have the value 0 and queue will have the value of what? Same value. If only a single person is there in the queue, that person is the first and that person is the last person. That person may be denoted as a front and rear, right? Isn't it?
Yes, sir, right.
Are you getting? All
Yes,
of you are
sir.
getting?
Yes, sir. Yes,
Yes.
sir.
Yes, sir.
And when the second element gets inserted, the value of the front will not be changed because front always keeps track of the first element. But value of the rear will be changed. Now the value of the rear will be what? 0 plus 1, 1, isn't it? When the third element it gets inserted, again the value of the rear will be changed, plus plus. Here the value of the rear will be incremented by 1. So value of the rear will become from 1 to 2, isn't it? In this case,
Yes, sir.
3. If there are 4 elements in the array, so definitely the value of the rear will be 3, 0, 1, 2, 3. In this way, when we will go on inserting the elements in the queue, always value of the rear will be incremented, but value of the front will remain fixed, unchanged. Got it?
Yes, sir.
Similarly, when we will keep on
Yes,
removing
sir.
element from the queue, value of what will be changed? Rear or front? Answer. When we will start deleting the elements from the queue, value of front or value of rear will be changed.
Sir, front.
Exactly. Currently, if the front holds this position 0, when this data is processed and this data is left out of the queue, front this front will not point here anymore. Front will now point here. The currently which is the front element. Okay, so value of the front will be plus plus. Now front will become 1. From 0 it will be 1. Then these data, after this data is also removed, then front again will point here. Front plus plus. Front will be from 1 to 2. Okay. So in this way, we will manipulate two parameters, front and rear. Value of the rear will always be changed when at the time of addition of the element in the queue, and value of front will be changed when we will start deleting the elements from the queue. Okay, this is what is shown here. Then uh, in which case we can say that queue is full when the rear reaches to the max size of the array, right? You can say that queue is full. Here in this case, if the queue means rear reaches 0, 1, 2, 3, if the queue rear gets the value 3, then we can say that the queue is full. Okay, so is the max size, maximum size of the array, right? Got it? Hello? Understanding?
Yes,
Yes, sir. Yes,
Mm. So in this case, if the rear gets the value equal to the maximum size of the array, then we can say it's true, it's full, otherwise it's false, right? Now, this is the general language. Algorithm is always written by the general language, but it maintains certain format to write, right? So this is the way of writing an algorithm in general English language, right? So here also you will maintain indentation to understand which condition is under what, okay, or which iteration is under what. But we will not use any convention of any language or C, right? But here we have used the convention of C. Now if the array size becomes, rear means array size, you know, if the array size is 4, then rear, when the rear will point 3, rear value of the rear becomes 3. So that is that implies the queue is full, right? 4 minus 1, 3, because the index starts from 0 in array. So if there are 4 elements, the last element will have the position 0, 1, 2, 3, 3. So if the maximum size is 4, so definitely I have to write max minus 1 to get the last position of the rear. Got it? So rear is max minus 1. If it is true, then queue is full. No more element can be inserted into the queue, right? Is empty. Is empty generally occurs in two cases. You can say, what are the two cases when we can say that queue is empty? Let me ask you. There are two cases. It is written here. When the front is less than minimum, minimum is 0 here, right? In array, the minimum value must be 0 because array index starts from 0. So if it is less than my minimum, just you say what you said, that if the front is minus 1, then we can say that queue is empty. And another case may be there, which we didn't discuss. See, if at the starting, when there are no element we inserted in the queue, that may be a case. Front and rear will point here, right? Minus 1 will have the value of minus 1. There may be another case. After deleting all the elements from the queue may be empty, isn't it? Shan?
yes, sir.
And why the others are silent? Huh? Ayanabu, Sneha, and so many other persons are
yes, sir. Yes, sir.
Obiji, Vidisha. Vidisha, are you there?
Yes, sir.
So why are you silent? Why
Yes, sir.
Soumi Kanungo, Udita?
Sir, I am hearing.
Okay, you can say, but I'm talking about Udita. Udita is there in the
Yes,
class?
sir. Yes, sir.
Okay. But why are you silent? Are you understanding what I am saying?
Yes, sir.
So please be interactive. Otherwise, see, in the virtual classroom, it's not possible for me to get your actual facial expression, right? In the physical classroom, you know, I come to know just seeing at your face. Okay, I can understand who is understanding or who is not. But at least in this case, in virtual class, you have to cooperate me. Otherwise, how would I know that whether you are understanding or not? So you have to be interactive, right? Got it?
Okay, sir.
Your real
Yes,
life
sir.
also, after to be an engineer, you have to be uh, interactive. Whether you answer always right or wrong, it doesn't matter, but you have to keep on talking, right? Otherwise, to make yourself a productive or sellable engineer, otherwise you can't uh, build your career in technical domain in that sense, in that way. Okay, so try to be
Okay,
interested.
sir.
It's not
Okay,
that
sir.
always you have to be right. It's not that, and it's not that I will be always scolding on you if you say wrong, right? At least you have to try. I have to understand whether you are mentally present, right, in the class or not. Anyways, let us come back to the discussion. So there may be another case when we have processed all the right. So the queue will be empty. So through which condition we will determine that we will answer. I repeat, if all the elements are left out of the queue, if all the data are processed in the queue, and queue is empty, you can say. Then by which condition? How will you put that condition? How my program will check that condition? Hmm? Answer. All of you try. Answer me.
Sir, if front equal to minus 1.
I'm not audible. Your voice is being cracked.
Sir,
Yeah.
if front equal to minus 1.
So that is a case what you have already told. If front is -1 means we haven't started inserting any element into the array. Right. Yeah, if the front comes here, points here, means we haven't started inserting the elements in the queue, isn't it? But
Yes, sir.
have
Yes.
inserted all the elements and we have deleted also all the elements, then definitely the value of the front will not come be -1, right? So one by one, see if the first
Yes,
element
sir.
processed, the front value of the front will come here, then here, then here. After that, value of the front will go where? Here, isn't it? We are getting the
Yes, sir.
value of the front when we intend to insert an element in the queue. So after the last element being processed, the value of the front will come here, na? And see, isn't it? When we are removing the element, always the value of the front will keep on changing, but value of rear will remain fixed. Value of rear will keep on changing when we are adding the elements in the queue, right? So at times when the last element being processed, the value of the front will go beyond the value of rear. So in this case, value of the front will be greater than rear, isn't it? See here 0, 1, 2, 3. In this case, Q is full. Okay. So value of the rear gets 3. If we start with 0, so 3, then front will be first will hold 0. Then this element is processed from front will be converted to 1. Then front will have the value 2. Now front will have the value 3. Here only one element is left to be removed from the queue. Value of the front and rear becomes equal. Then again, if we want to delete an element, then we are, as we are incrementing the value of front by 1, value of the front will have what? 4. So in this case, value of the front becomes greater than rear, isn't it? Rear, the value of the is unchanged. It points here. The front only will be changed by 1. So value of the front will come will come out as 4. So in this case, when we go beyond the boundary, value of the front will be greater than rear only in this case. Otherwise, value of the front will always be less than rear, isn't it? Got it? So this is what is mentioned in the algorithm. The second case, the front is greater than rear. Got it? Yes, front is greater than rear. You can see. Shantan?
Yes, sir. Yes,
Yeah,
sir.
Yes,
Vidisha?
sir.
Yes, sir.
Okay.
Yes, sir.
So, uh, uh, so it returns true. If this condition becomes true, returns true means the queue is empty. Otherwise, it returns false. So it is an algorithmic uh, language we uh, presented it this way. But in with the convention of C, how to write? Just we are implementing this algorithm in the code of C. Two cases when there are no elements, when we haven't started adding any element in the queue, the front of the value, what Santam said, this is front will have -1, means value of the front will be less than 0, or two cases may be there. So or is denoted by this, is this symbol. This front is greater than rear, front is greater than rear. Then it's written true. So in these two cases, we have to consider that our program will always check when to remove an element from the queue, right? Okay. So these are the steps for the enqueue operation. Check if the queue is full. If the queue is full, produce overflow error, exit, we will exit from the program. If the queue is not full, then I told you just now that always rear will be implemented, increment rear pointer to point the next empty space, then add data element to the queue location. On that location, the after rear points to the next room or next location, we add the element to that location where rear is pointing. Right? This is exactly step 5 return success. So here we are adding the elements. So in this position, rear points here, front remains unchanged. Okay. Then if you want to add another element D, so what you have to do, you have to first increment the value of rear here. So the rear will point here, the next location where we will insert this D, inserted this D. So rear will point the last location, right? Okay, got it?
Yes, sir. Got it.
We have written this algorithm. These steps we have. These steps are written in the form of algorithm here. If the queue is full, return overflow and the rear. Then, if not, then here with this uh, domain, our control will enter. So first we have to increment the value of rear by 1. Then in that position, the queue we have to store the data, return true. Fine. Now with the convention of C, we have written, we have to useful a function. I told you always in this data structure, you have to write functions. Okay. For each and every operations, we will write functions as a sub code, okay, or a sub program. Okay. So is full checking whether the queue is full or not. If it is full, then return 0. If not, then rear will be included 1 and queue rear is data, return 1. Return 1 means it's true positive. So end procedure. Now dequeue operation, similarly, I told you that while deleting the elements from the queue, we have to always manipulate the data of front. What we are dealing here. First,
Deallocate the memory.
deallocate the memory is a different concept. Here, physically, the memory will not be deallocated. Got it? Because here we are handling
Yes, sir.
memory allocation. Just the word you told, no? It is only valid for the dynamic memory allocation. When we will discuss dynamic memory allocation, that is linked list, then we will talk about the deallocate of memory. Here there is no scope to deallocate the memory physically. Here conceptually we are saying that the queue is full or queue is empty. Okay, queue is empty means it doesn't mean memory is becomes empty. Whenever we got it, the once you raise
Yes.
question,
Yes, sir.
yes
Yes, sir.
or no, no. Once you
Yes,
raise
sir.
the
Yes.
question, I should make it clear to you. That is,
Yes, sir.
deallocation is not possible in case of array. In case of array, once we define a size, we allocate a size, it is not possible for us to deallocate the memory physically at the runtime. Always we are talking about the running of the program during the execution of the program, right? Physically, you went there and just modify the size in the program. So that is not a point. We are always talking about the runtime event, okay, of a program. So at runtime,
Okay, sir. Okay, sir.
there is no scope to deallocate the memory. When we will be talking about this dynamic allocation, there is a scope to deallocate the memory or allocate the memory as and when required at runtime. Okay. Now see, it's not deallocate the memory. Conceptually, we are saying that see, this space is there, na. But conceptually, how will you say that which is queue is empty or which allocations will be there, right? So now we remove the first element, say A. Now front should not point here in this position anymore. Front will come here, so front comes here, right? So DQ operation, the algorithm. If the queue is empty, return overflow, right? We will not go for deleting the elements. If not, then only we will store the data in a temporary variable. Which data we are going to remove, that will be stored in a different variable, right? A different variable data queue front. With the index value of front, we can access the actual element of that position. Q is an array, Q is our array. Our array name is Q here. Okay. Now after storing that value in a temporary variable, then we will change the value of the front. Now front becomes front plus 1, return true. Got it? This algorithm. Now with the see what we are checking. We are first checking is empty function. We have to define that function beforehand, right? So the program checks this function, calls this function, and if it returns 0, then DQ is not possible. Empty. Probir Patro. Probir Patro is in your class. Probir, hello. Probir Patro. Sayantan, Probir Patro is in your class.
Yes, sir.
Probir, respond. Probir, Probir, respond. If you don't respond, whom I will be asking?
Sir, I think he's not there in the class.
Yeah, he has just joined the class. No?
Sir, he also
I,
joined earlier as well. But
yeah,
sir, he joined earlier as well.
I didn't. I can't hear you, Sayantan.
Sir, Probir Patro.
I just admitted Pradeep to join the class. He is there in the class, I think. Let me check. No, it's not in the list. But I just anyways, leave it. So coming back to the discussion, DQ is empty. Is not the if it is not, then we are storing the that Q in and we are just changing the value of the front. What I said, right? So in this way, NQ, DQ is empty or is full. These four operations we have to, mainly the two operations, DQ and NQ, and for these two operations we have to think about the two sub operations, is empty or is full, right? So this is all about Q, and next day we will show how to write code. Okay, how to write enter code. Here the code by piece I have discussed, isn't it? Right, some piece of code in the form of functions I discussed. The next day I will write enter program and I will show you how it is executing. Right, now let's form Q. Anybody have any question? You have any question?
No,
Anyone
sir.
question?
No, sir.
No question.
No, sir.
Okay, it's clear to all of you now.
Yes, sir.
So
Concept
let's
of
Yes,
clear.
sir.
okay. So let's move to the next topic. It's very interesting and very important. And at least some marks, only 5 to 10 marks, you will questions of 5 to 10 marks you will get from this topic. That is implementation of stack. The stack we discussed in the last class. So implementation of stack, a real life implementation of stack, right? See, what happens that have you ever thought that when you are uh, calculating some uh, expression, means when we are evaluating an expression, like say simple addition, 2 plus 5 comes out 7, right? How our computer or processor processes these mathematical expressions? The same way it is processed by the calculator also, but you know that there's huge difference between a calculator and computer, right? So anyways, so how our processor processes this one? 2 plus 5 is 7. It's very simply, right from our childhood we are used uh, to write the expression in this way. Let's say in generic form, if summation s equal to a plus b, we write in this way, na? Isn't it?
Yes, sir.
But does computer process these mathematical expressions the way we process? Truly no. Okay, computer doesn't process in this way. The mathematical expression what we used to write from our childhood, like say in the form of a plus b, computer doesn't take. Computer takes this expression as an infix expression. It's called infix. But computer has to convert this infix expression in some another form. Two forms are there. One is postfix, another is prefix. So let me show you this concept in a presentation. My screen is visible. Screen is visible.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
The topic is data structure expression parsing. Okay. I will be giving you the notes. So I'm not just merely reading out the notes. You will give this infix notation what I just talked about. Two forms may be there which is processed by the computer. One is prefix, sometimes it's called Polish notation, and postfix, sometimes it's called reverse Polish notation. This is a simple infix expression, means the form we use to write an expression, right? Infix expression. Computer takes this expression as an input, but before it processes this expression, it has to convert it either in postfix form or in prefix form. In postfix form, in prefix form, if a plus b is there, we will convert, the computer will convert it in plus ab, and in postfix ab plus. Here what happens, a and b, these two parameters are called mathematically operands, and this is our operator, right? These a, c, the variables we use in mathematical form, mathematical expression is called the operands, and the operators which are associated with these operands are called operators, right? plus, minus, subtraction, multiplication, okay, division, all this, expansion. So here with by prefix notation, what happens? This operator comes first, followed by that two operands associated with it. So plus AP. So that the operator comes first. And here means operator followed by the operands, but here operands followed by the operator. In postfix, it comes out at AB plus. And always the way we process, mathematical way, we always gives us the priority according to the precedence of the operator, isn't it, Sandeepan? Shantan?
Yes, sir.
We always go for precedence. Here always the expression which will be there within bracket will be processed first, because the closing bracket has the highest priority, has highest precedence, right? So A, this expression will be processed first because this is within the bracket. So if we generate a single token from this expression, we will get, according to the prefix notation, plus AB. Now plus AB will be treated as a single element or token. Now our expression will be derived as plus AB, then star and C. Got it? So while writing these, while converting this NP expression to prefix or postfix, you have to write, you have to show the step by step forms, step by step forms. So then what you will do, you will write A plus AB, then you will put an underline under this single token, right? Now then star and C. After that star will come first. So star plus AB and C. Got it? This way, here it will form AB plus. This AB plus, this AB plus, it will be treated as a single token, right? It will be processed by the computer first, then star and C. Let's say this AB plus, just assume it as as X. Okay. Then X star C. Then what will come? X C star. So AB plus C star. In this way, this is also in this way. So in every exam, generally you will get a question. In the previous also I have seen that you will get at least one or two questions from this rotation. You asked to, you will be given a large expression in this rotation, and then you will be asked to convert it into prefix or postfix. Got it? So I will be giving you some assignments where only you have to convert these expressions, that expression, into prefix or postfix notation. Okay, very easy, very easy. But step by step forms you have to show, and it will be easier for you to avoid errors. Otherwise, if you just calculate with your mind and try to write the final expression, you may make mistakes, right? So to avoid that mistake, you have to always follow the step-by-step forms, and that is also good to get marks. Okay, this
Okay.
this is division.
Okay, sir.
Division gets the first priority, right? Prefix notation, then this division AB, then division CD, then this is a single token, so division AB and division CD. X plus Y. Now plus XY means plus division AB, division CD. Okay, in this way it has been generated. Okay, so I'll be giving you some example to work out. Okay. So now parsing expression. Now you have to actually write the algorithm. There is a program we have to write with the algorithm to convert an input expression to postfix, an algorithm to convert an input expression to prefix. We will discuss the algorithm later on. Okay, these are the what we have discussed. It's just right the precedence, sensitivity, all these are okay. Postfix. Now next, how it evaluates, how it gets evaluated by the system. Ultimately, after after generation of these, after conversion, the input expression to postfix or prefix, eventually the computer, this processor has to process, has to evaluate this expression. So that is there is a specific algorithm. So this algorithm is for postfix evaluation, and another prefix algorithm also we will discuss. Okay. So let us stop this today's session. We will not discuss any more. The next day we will first complete. We will show how to write code in for stack and queue. Then we will go for how to write, how to convert the expression into postfix and prefix, the algorithm for conversion, and we will also write the codes. Okay. So any question from today's discussion? Any question?
No,
No,
sir.
sir.
No, sir.
Okay. So I had given an assignment. Got it?
Yes, sir.
And due date also is mentioned. So I will not tolerate what we did to you in the last week. So many of you uh, uh, failed to submit the assignments in time. So from this week onwards, you have to submit the assignments in time. Otherwise, it will be reflected in your evaluation also. Okay, fine. So let us end the session. Okay.
Okay, sir.
Okay, sir.
Thank you. Thank
Thank
you.
you, sir.
Uh,
Thank you, sir.